Welcome to Lesson 68 in Saxon's third edition of Algebra 1. This lesson is about complex fractions, and I thought this little cartoon was humorous. The little boy tells his teacher, to show you how well I understand fractions, I only did half of my homework. A complex fraction is an expression that has a fraction in the numerator, in the denominator, or in both. And these are some examples. 2 over x minus 7 over x. Remember that this main fraction bar here means divided by x. Alright, and here we've got 5, which we could make 5 over 1. And then the main fraction bar here divided by m over n. And then here this even looks a little more complicated. A squared minus 16 over a plus 2. All divided by a minus 3 over a squared plus 4. All right. This sounds pretty complex, but it really is not any different than simply dividing fractions. So here's a brief example. If I have 7/8 divided by 2/3, I'm going to rewrite it as 7/8 divided by 2/3, and then I know that the second fraction, or the bottom fraction, has to be inverted and multiplied. And then I would get 7 times 3 is 21, 8 times 2 is 16. Alright, in this case, we've got a numerator and a denominator. So here, if I wanted to divide, I would flip this one, and whatever I do there, I've got to do here. These all cancel each other out, and these would multiply to 6 over 20, or if I had reduced, that would be 3, that would be 2, and that would be 3 over 10. And that's all there is to it. Let's do this one. 10 over 8, 10 over 8. This all cancels out, and this would be, let's see, that could be 1 and that 5, and that would be 15 over 8. Alright, now in this one you've got 2/5 divided by 3. What you need to do is remember that the reciprocal of 3 is 1/3. You can make it 3 over 1 if that helps you, but you're going to divide by 1/3, which would give you 2/15. Here the 4 is a whole number, so just go ahead and make it 4 over 1. You haven't changed the value. Flip this and multiply, and you would get a value of 20 over 7. Alright, so I've done some from your book for you. We've got, the first one is x over y plus 1 over y, all divided by x over y minus 1 over y. Alright, well, I can simplify that a little bit. These both have the same denominator, and so do these. So really all I've got is x plus 1 over y divided by x minus 1 over y. If I invert this bottom fraction to y over x minus 1, and I've got to do that on the bottom and on the top, same thing, then this, and this should cross cancel out, leaving you with this over this, which is your final answer. Alright, here I've got 1 over x divided by 1 minus 1 over x. Well, the first thing I'm going to have to do here, this one can stay just like it is, but this one is going to have to be added. So I'm going to have a common denominator, which is x. So I've got 1, which is x over x, minus 1 over x. Now I've got a common denominator of x, and what I have left is x minus 1 over x. So, now I have 1 over x divided by x minus 1 over x. I'm going to flip this one to x over x minus 1, and you can see then that cross cancel out, leaving us with an answer of 1 over x minus 1. Isn't that fun? Not hard at all. What you guys are not going to like is that it's extra work. It's a lot more work that needs to be shown, and that's all right. All right, so here in this top one, I've got to get a common denominator. It is going to be b, because 1 over 1 and b, it's still going to be b. So I add these two fractions and I get a plus b over b. I'm going to move that over here. Now I've got to add these. Now this is 4 over 1. Remember, I did this over here. X over b plus 4 over 1. Get a common denominator of b, or 1b. And this one is going to stay the same, exactly the same. This one, though, is going to become 4b, because I have to multiply by b. So now what I have is x plus 4b over b. That is my bottom fraction simplified. Then I simply flip that one and cross cancel here, 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 and what is left is my answer. So a plus b over x plus 4b. Alright, your practice problem A. I have 1 over w plus c over w equals 1 divided by c. Alright, this already has a common denominator, so all I have to do is put 1 plus c over w divided by 1 over c. See, this one's really easy. Flip this one and multiply on top and bottom. This and this should cross cancel out. Alright, when I multiply here across, 1 plus c times c, and I'm just going to leave it like that for right now, okay? And w times 1 is w, okay? Alright, here's one that looks like a lot of work. I have 1 plus m plus 5, and that 5 was a whole number, so I just made it 5 over 1. And then all of that is going to be divided by 2 over m minus x over m. Now this one is the easy one. It already has a common denominator of m, so I'm just going to simply change it to 2 minus x over m. This one, however, we're going to have to, these two need to get a common denominator. So that is going to be m, and I have this one is going to change into 1 plus 5m over m, because this right here I have to multiply by m, 5 by m. Alright, now this is nothing new, we've been doing this. So I rewrite my expression as 1 plus 5m over m divided by 2 minus x over m. When I do that, what I need to do is invert this bottom fraction and then do it on bottom and top, multiply, cross multiply out, here, here, and here, here, and what I have left is 1 plus 5m on the top and 2 minus x on the bottom. Alright, now this one looks a little different, but there is one in your book that's a lot like this. We're going to have to rewrite it in a more standard form with all the exponents being positive. So that would be a over x plus b over y divided by 1 over x. Alright, now I'm going to get a common denominator here. For x and y, it is xy. I'm going to do my multiplication, and when I do that, I'm going to come up with ay plus bx over xy. That is what my top term simplifies to. That becomes this. Alright, and I'm going to put it right there. And the bottom one doesn't add to anything, so it's just going to stay 1 over x. And then I'm going to multiply by its reciprocal of x. Alright, now look closely. When I do, this and this cross cancel, 1 and 1 there would cross cancel. This x and this x cross cancel each other out. But I do have y left on the bottom. So all that I have left is ay plus bx divided by y. And that's my final answer. Good job. Keep plugging away. Please keep showing your work. That is so, so, so important that you show your work on, especially on these kinds of problems. Okay?